Okay, section 1.9, the design problem, objectives, functions, and requirements. This is a lecture on a section from my book that I wrote with Garbini and Devine. I'm Piccone. MIT Press published it. Check out their website. This is also the companion website for the book, rtcbook.org. The design problem. This course is oriented around a design problem, one that you presumably don't yet know how to solve, but which will be solved as we progress. We begin with a client problem, stated from the perspective of a client for whom we are designing the target system. Here it is. A user should be able to precisely control the angular motion of a rotating mechanical load. The user should be able to control the velocity by entering a number into the system. They should see a display of measurements of the velocity. In addition, a technical user should be able to load predefined angular position trajectories into the system, which should be followed precisely. They should be able to obtain measurement data for these runs. Okay, so this is the client problem. This is what we're trying to solve with our real-time system design. Functional requirements. In a typical design scenario, we, the designers, would spend a good deal of time with the client and potential users clarifying their objectives for the target system. Suppose we have done so, developed specific requirements, and have performed a function analysis of the system. Further suppose that we have even determined that the target system hardware described previously can be made to satisfy the requirements. For the context of a course and a book, this is what we have to do. The following functional requirements have been identified. R1, requirement 1. A user can input numbers interactively with an input device and display. R2, a user can view prompts and messages on a display. R3, a user's commanded velocity of rotation of the mechanical load is achieved quickly and accurately. And requirement 4, a technical user's commanded angular position trajectory of the mechanical load is achieved quickly and accurately, and they can obtain the position data. So those are the 4 requirements that we're going to use. Functional analysis. Consider the target system operational diagram shown in the figure, right here. There are 5 functional blocks that can achieve the 4 functional requirements. Input numbers interactively. So this block. This block supports R1, the interactive user input of numbers. The control block in the middle here receives the user input and controls the displayed feedback to the user. Okay, so we have this interactive input of numbers between the control block and the input numbers interactively block. Display prompts and messages. This block, shown right here, this block supports R2, displaying prompts and messages to the user. The control block determines what messages should be displayed to the user and when these messages should occur. So that is the direction from the control block. Actuate rotation. So this block right here. This block supports R3 and R4, actuating the rotation of the mechanical system. The control block determines how much actuation is appropriate. Since velocity and position, this is the block. This block supports R3 and R4, measuring the angular velocity and position of the mechanical system. The control block receives these measurements. So the mechanical system is measured through the sense velocity and position block, and that measurement is reported to control. Finally, control. This block supports all the functional requirements. It controls the UI as well as sensing and actuation of the mechanical system. Furthermore, it is playing the role of feedback controller for the mechanical system. So those are our 5 functional blocks that support our 4 functional requirements. Expanded functional analysis. Each of these functional blocks contains lower level blocks as shown in the figure. So what we've done is we've expanded each of our 5 functional blocks. This is what functional analysis does, is start with high level functional units and then expand them to smaller functional units until they're the right size for implementation. The real-time target computer is well suited to perform the control function. So we see the control block in the middle is the target computer. And the blocks in the target computer are named for the primary C functions that we will write to instantiate the design functions. So double in, which we are writing in this chapter's lab exercise, interacts with the user for the input of numbers through the LCD and the keypad. So the user can key in numbers and view the numbers that they're keying in on the LCD. The LCD is also used to display prompts and messages controlled by the printf LCD function. So we see also in control the printf LCD function that interacts with the user through the LCD. It displays prompts and messages. Good. The control loop, including the mechanical system, is governed by the cascade function. So this function here, which commands the amplifier to supply appropriate electrical power to the motor to actuate the mechanical system. Amplifier, motor to actuate the mechanical system. So the motor is an electromechanical system, and on the mechanical side, it is moving around the load. The encoder sends the position measurement to the cascade function to complete the feedback loop. So we sense the position and implicitly the speed. So that's the control loop. Okay, so this is a functional analysis, very high level view of what we're going to be doing in this course, in this book. We're going to learn how to write these high level functions and then also the lower level functions below them that support these high level functions. So if we look at it in the context of this functional analysis of our design problem, we have a better roadmap for where we're going. Right now, we're working on the user interface. So we're going to be working in double in, printf LCD, etc. But we're going to work our way up to Cascade, which is going to implement our feedback controller, our digital controller for this feedback control system. Okay, I'll see you next time.